Hello guys, can you hear me?
Yes, sir.
Great. So yeah, it's 6 o'clock and I believe we should begin. So my name is Vikram and I am a PhD student here in IIT Kanpur, and I'm one of the TA. There are two TAs for this course, and so we will be assisting you throughout this course with your assignments and any doubts that you have. All right. So since it's a week 0, so we don't have anything to teach actually, because uh, since you do your assignment 1, then we solve that assignment, right? So I'll just give you some brief intro to what aircraft design problem is, some fundamentals to begin with. So that is my job today for week 0. All right. So I think we should begin. We have enough people. Yeah. All right. So you see 6 photographs, right? Now, can you tell me which aircraft was made by who? I mean, what is the main focus of a particular picture? Let's start thinking about picture A. So since it has to be an interactive session, I will ask you questions and you have to answer. Right, wrong, doesn't matter, because if you interact, you learn. So any one of you, think about picture A. Who do you think made picture A, or the aircraft picture A? Okay, so I'll give you some hint. There are multiple groups, let's say 6 groups. One is flight control group, aerodynamics group, propulsion group, manufacturing group, structural group, weight group. So now you have to choose which design is made by which group. Let's begin with A again.
Maybe structural.
Okay, anybody else? What's your name?
Ripinder Singh, sir.
Okay. And you are from?
I'm from MIT University.
Which one? Noida, Gurgaon, where?
Noida.
Noida. Great. And you will be surprised, I am also from MIT in my BTech. So
Oh,
yeah,
that's very nice. I'm also doing BTech in aerospace engineering here only.
good. So we have aircraft A, and one answer is structural group. Anybody else?
This is Akash here.
Yep.
That is a structural
Group, right?
Yeah.
So my next question is, why do you guys think it's a structural group? What are the indications? What are the indicators? What do you see in picture?
The main spar is an I-beam showing here.
Yeah.
And the fuselage as well as an I-beam.
Very good.
According also the support structures from the fuselage to the spar and back at the horizontal stabilizer.
Very good. So this is the focus of structural design, right? So therefore the answer for picture 1 is structural group. And how about picture B? I want everybody to participate. So I want other people, Akash and Ripinder. Apart from these two people, I want other people to join. So which group designed aircraft B? I won't go ahead until you people answer. Okay, because it's a
Can
2
you
hour.
give me the options, sir?
Yeah.
This is Akash here again. Can you
Okay.
please give me the options one more time?
Yes. Your options are structural group, flight mechanics group, weight group, propulsion group, aerodynamics group, manufacturing group.
Sir, may I?
Yeah, sure.
Maybe it is weight group
Yeah, weight.
for
Yeah,
maintenance.
maintenance.
Maintenance was not an option. Manufacturing was an option.
Manufacturing, sorry, manufacturing.
Yeah. So if you look at the weight, the volume is high, and it looks like a cuboid, so it takes a lot of weight. So it's probably not the weight group. It is the manufacturing group, because these are simple rectangular bodies and it's easy to extrude, right?
Easy
So
to manufacture, yeah.
yeah, it's easy to manufacture. So picture B belongs to the manufacturing group.
I-
And how about picture C?
Aerodynamic.
Aerodynamic.
Who
Aerodynamic.
answered? Who answered?
Only.
Om Gaikar. Very good. This is aerodynamics group. And what are the indicators, Om? What do you think are the indicators for aerodynamic properties in this picture C?
I guess it's not much complicated. It's only focused on the wings.
Yeah, right. And how about D?
Sir, it's not in streamline shape, sir.
So what do you think? Picture D belongs to which group? Okay, one hint is that they're trying to inject more air. What do you think they need more air for?
Propulsion.
Very good.
Propulsion.
It's propulsion group, because they want to generate thrust and they want maximum air, right? Pass through engine. They don't care about wings or tail. They just care about the engine, right? So it's the propulsion group. How about E?
It is a very simple glider,
Mhm.
but group wise I can't say.
No, it's a
Sir,
trust structure.
sir,
It's a trust structure. Yeah, Hegriv, go ahead.
sir, they are trying to increase the wingspan area to increase its efficiency.
That's right.
It's weight group.
Yeah, who answered this question? The weight group?
Akshay Singh, sir.
Akshay Singh.
Yes.
Good, very good, Akshay. Because it's a trust structure and they want to minimize the weight. So their focus is only to reduce the weight, right? They don't care about anything else. Now the last one belongs to which group? Someone's microphone is active. I don't know which one. Yeah, thank you. I think it's Gunis. Gunis Kaushik, can you hear us? Yeah, his microphone is off now. Now, guys, how about picture F?
It has many wings, so
Like
it is trying to create a lot of lift, maneuverability or increasing they are trying to.
flight control mechanics.
Yeah, it's flight mechanics group. And there are not many wings. Wings are only one, but the
Other two
they are
are
called usually control surfaces. Yeah, canard or tail. So these things are called control surfaces. So it's the control group, flight control group, right? So they want maneuverability as high as possible. So they put everything, canard or tails and everything. All right. So now you guys have been warmed up. You have some understanding about what different groups really focus on. Okay. Now, when you design an aircraft, you can't design alone. You need communication among the groups. Aerodynamics people should talk to flight control group, and they should talk to propulsion group. Same thing goes for weight group, manufacturing, and structural group. So without communication among these different groups, you cannot arrive at a very good design. So this picture gives you a sense that if you are a loner in a structural group, you will end up with not a really good aircraft, right? So it's an interdisciplinary problem. Designing an aircraft is an interdisciplinary problem. In one course, you can actually learn about its structures. You can learn about its manufacturing or aerodynamics or propulsion or maybe weight reduction techniques, right? Or maybe you can make it highly maneuverable. So this particular course that Ghosh sir is taking, it's more focused on flight mechanics and aerodynamics. Okay, we choose the engines off the shelf. We do not really care about the structural aspects. So you can think A, B, and E. We're not really bothered about these three. What we really bother in this course about C, D, and F. And about D, the propulsion, we actually choose off the shelf engines. We just say that we need this much of thrust. So we are either going with a propeller driven engine or a jet engine if it satisfies the thrust requirements. So major focus of this course is on the aspects of aerodynamics and flight mechanics. Okay. So now we go to next slide. How do we go to next slide? Yeah. Now this diagram gives you the sequence how aircraft design happens. So what's the procedure? So your customer could be maybe an airline or maybe some government. They need some aircraft. So you are specified some requirements. You have a particular mission. You want this mission to have certain performance. Your aircraft must have certain performance while executing this mission. And I want to understand from you people, what is the performance of an aircraft? What do you care about in performance? You're free to answer, anyone. What do we mean by performance of an aircraft?
Basically efficiency and the power and transmission stuff.
Power and transmission stuff. So you're more focused on the propulsion side, right?
Yeah, correct.
Right. Anybody else?
Like about the mission profile, how much distance it can take off and land, how much loiter it can do, the cruising, maximizing endurance of the aircraft,
Right.
like
So
you said.
I think this answer is more closer to what you will be learning in this course. In this course, performance of an aircraft actually means how fast you can climb, the climb rate of the aircraft, right? What is the range of the aircraft? What is the endurance of the aircraft? Okay. So these are the characteristics we care about in performance here. And the next term is stability. You are given some stability criteria. So to give you an example, military aircrafts, usually the fighters, they are close to instability. They're very close to instability. They're not really statically stable. They are designed like that. So if you are a government and you are buying some, if you're giving the designer some requirements, so you're telling them we want it less statically stable so that it can become highly maneuverable. You want it to do crazy maneuvers, right? And if it's stable, then it will be hard for the control surfaces to make it move. Okay, so stability. Now, because I expect that all of you have gone through some fundamental courses like flight stability and control. So what does stability gives you? What comes to your mind when you hear stability of an aircraft?
That upon any destabilization by any wind gust, the airplane will come back to its original position.
All right. Anyone else?
Sir, it will be easily maneuverable.
Mm-hmm. Anyone else?
Balancing of
Well,
weight and
Balancing of
Can
weight.
you
So the ability of an aircraft to correct for conditions that act on it, flight control input, something like that.
Sir,
What
can you
kind of-
repeat the question? My net was lacking. I didn't
Okay,
heard.
so the question is, what do we mean by aircraft stability? Somebody has sent a message in chat. Better mission result. Okay.
Some more safety of passengers.
Okay. Okay, so one of you, I don't remember the name, but one of you has answered the question correctly. It actually means when the aircraft experiences some disturbance or rather perturbation. Let's say it is flying in cruise. Now you experience some wind gust. Okay, so your angle of attack increases. But if your aircraft is statically stable, it will bring back to the original angle of attack. It has a natural tendency to come back to that original equilibrium. Okay, if it doesn't have, let's say you perturb it, your angle of attack was, let's say, 5 degrees, a wind gust made it, let's say, 10 degrees. Aircraft has more lift now at 10 degrees, and then aircraft goes to the 90-degree angle of attack and it just topples. So that is unstable aircraft. So what a stable aircraft will do is, you're flying at 5, all right? You're flying at 5. Who is writing? We can see your name, Soumya. I mean, so now you're allowed to write, but then you have to
Sorry, sir.
remove these things.
Mistakenly right.
Yeah, you have to undo all of this, because this lecture is being recorded. It will go to YouTube.
Okay, sir.
Yeah, so we'll upload this, and I think you should undo all of what you did. You have an option in your Zoom, I believe. Please do it quickly, because time is passing and people will be unhappy when they see it. Yeah, someone has raised hand. All right. So, all right. So let's move ahead. I don't think he's able to do this. Now, this is the next requirement we are given is the operational environment. What kind of operational environment in which the aircraft will be operating? Let's say you want to make an aircraft for a aircraft carrier. So your aircraft sits on the aircraft carrier most of the time. Then it's experiencing more moisture because it's in ocean, right? So you want the material properties to sustain that, right? So that can become your design requirement. Then you tell that, okay, we need this in 5 to 10 years of time frame, and we have these kind of manufacturing facilities. So these kind of requirements are prescribed. They are specified. All right. Then as a designer, you have to identify how do you translate these requirements into specific properties of these major components of the aircraft. Now, what are the major components? You can see the list on your screen. First is the wing configuration. There are multiple configurations for the wing, and then same goes for the tail. You have multiple options for the tail that you want to choose for your aircraft, such that you can satisfy the design requirements. Same goes for the engine. You have guys, I think you should mute yourself when you are not speaking. All right, it's good now. So same goes for the landing gear. You have multiple configurations. For structure, you have configurations. Same goes for different mechanisms on the aircraft. And when you combine all of this, you get an approximate design of the aircraft. Okay, that is not your final answer. Then you have to perform some optimization on whatever you have chosen, and then you get a final optimum configuration of the aircraft. All right. So now we will move ahead to the next slide. Oh boy, I think you guys have to remove these things because they will be on every slide.
The one did this can only erase it.
Exactly, that's what I know. So Soumya, you have to undo whatever you did to this screen, because it will be for all the slides. That's not a good idea.
Yes, sir. I am trying, sir.
Yeah.
There's an option for undo, Soumya.
Yes, sir.
Okay, so we can keep talking. Now, we must understand what are the functions of different components, because as a designer, you're choosing properties of those components. Okay, so you should know their functions and what is the impact of different components on the properties of the aircraft. So we begin with the fuselage. Now, you cannot have a arbitrary size of the fuselage. You want the fuselage to have a certain size based on how much payload you want to accommodate in that fuselage, right? You cannot choose very large, you cannot choose very small. You want to choose it such that you can accommodate the payload that is available to you. Now, not only the payload, the fuselage will be impacted by the performance. It will impact the performance of the aircraft. You will understand at some stage in stability control course or maybe in the design course, fuselage has an impact on the stability, lateral and longitudinal both stability, and what kind of fuselage you're making, it has an impact on the manufacturing cost. All right. Now, the next component is wing. The primary function of the wing is to generate lift, and wing affects lateral stability and the performance of the aircraft. Now, horizontal tail, it's required for longitudinal stability. You will understand this and you will perform, you will do some questions also on sizing of the horizontal tail, sizing of the wing. Okay. And horizontal tail is useful for longitudinal trim, and it helps you in control of the longitudinal motion. Now, the primary function of the vertical tail is directional stability and directional trim and control. Engine's role is to generate thrust, it impacts aircraft performance, and the kind of engine you choose, it may have a certain stealth characteristic. For example, if you have a very high infrared signature, so your engine is not good for stealth, right? You want to have it, you want to have a minimum signature for sound and infrared. You choose landing gear for taking off and landing. It impacts stealth, cost, and aircraft performance. And we already know that control surfaces impact the maneuverability of the aircraft. You know, as many surfaces you have an impact on maneuverability. Okay. So we go next. So this slide has different options for the wing. Okay. Different options like high wing, mid wing, low wing. During the course, Ghost sir will teach you how high wing is useful, what are the disadvantages of mid wing, why you should not go with low wing in what cases. So I'll give you some very brief idea, not a detailed idea. You'll get these ideas throughout the course. My job is to introduce you to certain configurations. Now let's look at the high wing. Can anybody tell me what is the advantage of a high wing? Any advantage? We'll talk about disadvantages also, but let's focus on some advantage of a high wing aircraft.
It's
Some
inherent
more
in air
maneuverability.
stability.
Say it again because I could not hear.
So it will be more
It's
stable, sir.
enhanced
In
stability.
high stable.
It
The
will be
increase,
stable.
yes, more stable, sir.
It will make aircraft more stable, right?
Yes, sir.
Okay. Now, you know these, a certain class of aircrafts, the cargo aircrafts. Now, when you load and unload cargo, your loading truck, the truck might need to move below the aircraft wing also, right? So for the high wing aircrafts, there won't be a collision between the wing and the loading truck. So you have an advantage for the cargo aircrafts, and you will find out that most cargo aircrafts are high wing. So there is a certain advantage associated with a certain configuration. All right. So these kind of advantages and disadvantages, they guide you what kind of configuration you want to choose. Okay. So same goes for the mid wing and the low wing. Now, can anybody tell me what is one advantage of a low wing? So
Some more movement, like we can move in air more fastly.
we
can change
move in
direction.
air
Yes.
more fastly.
Yes, sir.
Anyone else? Okay, so I'll give you a hint. The low wing is very close to the ground. How does it help in lift? When you have a wing very close to the
It
ground,
increase ground effect.
exactly. So it increases ground effect, and you will have very good lift and takeoff characteristic. Okay, so low wing is advantageous in that sense. Anybody tell me any disadvantage of the mid wing? Any advantage you can, a disadvantage you can think of for the mid wing? Yeah, Rohan said low wing, shorter undercarriage. Very good advantage. So your what do you call it? Your landing gear size will be small, so low weight for the low wing. That's another advantage, Rohan. Thank you.
So
Any?
the wing,
Mhm.
so the wing will have to either pass through the fuselage or something. So into eating into usable volume, or the structure has to be straight head around the fusible uh, to carry the loads.
You are absolutely right. Basically, she's trying to say that when you join the you construct the fuselage, so it has two parts: the top part and the bottom part, and your wing is being attached to that same part in the mid section. So you need more reinforcements to support that structure, those bending moments that will come on the root of the wing. So mid wing is slightly disadvantageous structurally. Okay, now what kind of plane form you want for the wing? You have options like rectangular, tapered, swept back, and delta. They have different advantages and disadvantages. There's a list of that. So what kind of configuration you want to choose depends on what kind of aircraft you want to make. What is the specification in the requirement table? You have a table for the requirements, and based on that you want to translate into a plane form configuration. uh, the next is you have a monoplane, you can have biplane and a triplane, you can have a fixed wing, and you can change the sweep in the flight also. So the variable sweep wings do not
Sir,
have.
what are the different uses of rectangular and tapered where they are used? Sir? Can you give some examples?
Yeah. So this is question to everybody.
Please
Why
repeat the question.
the question is, why would somebody prefer a tapered wing over a rectangular wing?
Tapered wing will be having a better aspect ratio.
And who was this?
Ripinder sir.
Okay, so that's a good answer. Can Ripinder, you don't answer this question now. The next question is, how can tapered wing increase the aspect ratio? Other people have to answer. How can a tapered wing increase the aspect ratio?
So the tapered wing can produce more lift compared to rectangular wings.
All righty. So this is the aspect ratio, B squared divided by S. Now tell me, how can a tapered wing has more aspect ratio for the same wingspan?
Sir, may I?
Yeah, sure.
As we go from the root to the tip, the chord keeps decreasing, which will
Okay.
decrease the S and hence increasing the aspect ratio.
Yeah, you can see in this formula. For the tapered wing, you have less area for the same wingspan, and that's why you have more aspect ratio. And if you have more aspect ratio, what are the advantages of having more aspect ratio? Anybody?
So may I?
Yeah.
So the tapered wing can produce more lift compared to rectangular wing.
And why is that? Rohan is answering in the chat. The answer is really good. Less induced drag for the high aspect ratio. That's good. And one answer is shock formation. So the swept back wing is used to avoid the shock formation. That is also a good answer. Same goes for the delta wing also. You will find that these fighter aircrafts, they fly maybe close to supersonic or supersonic, and they have delta wings or swept back wing to avoid the shock formation on the leading edge. Okay. So the big thing here is we want to have idea about all possible design configurations, right? As a designer, we want to have this knowledge, and we want to have a list of advantages and disadvantages associated with every configuration. So tomorrow I give you a design problem. If I give you a design problem, you'll be able to choose one configuration based on your knowledge. All right. So that's the purpose. Let's move ahead. Now we have options for the tail. So one is conventional tail, T-tail, V-tail, and H-tail. In conventional tail, how many components can you see? How many aircraft components?
Two, sir.
Which one?
Two. The radar and elevator.
Rudder and elevator. I think rudder and elevator are part of the horizontal tail and
Yes, it is horizontal stabilizer and vertical stabilizer.
yeah, so that's the component we can see in the conventional. Same thing happens for the T-tail. You have a horizontal stabilizer on top of the vertical stabilizer, right? What happens in V-tail? I don't see two separate components like elevator and rudder. Anybody has an answer for that?
Elevons. They work as elevons.
So what about the function? Let's say elevator's function is to control the pitch. Now, how will you control the pitch through V-tail?
By deflecting both the surfaces up. If we're seeing it from front side, the V shape, the elevator, the elevons have to deflect up, both of the.
Anyone else?
Deflect both flaps and elevons.
Yeah. All right. So you guys have got idea about this. All right. So the thing is, this V-tail, you have to move both the surfaces simultaneously. So they will be contributing towards pitch moment. They will be contributing towards the yawing moment. All right. And rolling moment also. So these two surfaces, they move simultaneously. So you have to form a allocation matrix, right? Let's say you want only pitch. So in what manner you want to move them? Okay. So the command that you compute for V-tail depends on a configuration matrix. You have to form a matrix, and that matrix depends on the aerodynamic properties of these two surfaces. In V-tail, I think you can clearly see the roles. It's also, the roles are different. All right. The location of the tail, we have aft tail, we have a canard, and we have three surface configurations. Okay. So I think you are aware of the role of the tail. What is the role of the tail? Main role of the tail?
To climb or descend.
So to give horizontal stability.
May I, sir?
Yeah, go ahead.
So to provide horizontal stability.
That's not called horizontal, it's called longitudinal.
May I, sir?
Yeah.
It will help to give us the controllability of the aircraft, pitching and yawing direction. Also stabilizing the aircraft.
Yeah. Many people have answered in the chat longitudinal stability. That's a good answer. Very good. You guys are aware of it.
Longitudinal and normal.
Yeah. And how about canard? Can canard replace the horizontal, sorry, the aft tail? Can it provide the function of a tail?
Yes, sir.
Yes, sir. Because this type of configuration will fight mostly in fighter jets, no, sir.
Okay. Can anybody answer me in detail? Since you have done this flight stability course, I hope you have done that. So if I place a surface right ahead of the wing, it will have some lift component. So how it will impact the stability? Will it be giving a stabilizing contribution to the longitudinal stability or destabilizing?
It will be
Sir,
destabilizing.
destabilizing, sir. It will increase the movement speed, sir, but stability will decrease, I guess.
All right. I think it has a destabilizing contribution. So how can a canard configuration fly stably? How can you provide stability to this canard configuration?
By
Sir,
placing
by having delta wing.
No. We are having this same exact configuration too, and we want it to be stable. That is the problem. Now tell me, since this tail is destabilizing, definitely, what would you do? What kind of design change you perform so that canard configuration can be made stable?
Sir, may I?
Yeah.
We need to make the position of the CG in between the main wing and canard, so that the movements will be cancel outing each other.
So okay, you're going in the right direction. So what is the design parameter that you're going to change? What would you change? Location of the wing.
Look,
Where you
yes, sir. Look, wing will be
so the
placed
mounting
back.
location of the wing has to change in order to make it stable in canard configuration. All right. Let's
Sir, I
see.
didn't got that. May you explain in a little detail, sir?
Can you ask again?
I didn't got that.
That how can canard configuration be made stable?
Yes, sir.
All right. So the idea is this. Let me give you the idea. Wait. Pen. Yeah, we have the pen. So the idea is this: you have this fuselage reference line, and you have one component sitting here. It's providing you lift. You have another component here providing you lift, and you have some weight. Your weight is acting like this. So since you have already mounted this here at a certain length, let's say call it L1, call it L2. Now, my question was, let's say the wing was here and wing is here at the exact same location, but you are moving this tail ahead of the wing. So what would you do? What kind of design change you would do? You will definitely change L2, right? That's the only variable you can change and control the overall moment to be 0, or you can provide it basically the static stability by making the lift this moment slope negative. Now we are getting the idea. If you have done this stability course, I think you will get the idea. If you did not get, we can discuss it when it appears, because the questions will come.
Okay, sir. Thank you, sir.
Did you get the idea or not?
Yes, sir. Little bit.
Yeah, fine. So this slide gives you where do you mount the engine. You have a tractor configuration, you have a pusher configuration, tri-engine, 4-engine. Now the question will be, why would I go with one? Which one? And that question is answered best by having a requirements table. So as a student of aircraft design, your job is to understand various possibilities. And my job to show you these slides is exactly that. You should know what are the possibilities and their advantages and disadvantages, right? So these are different possibilities for us. There is possibilities for the landing gear. You can have a tail gear. One of the wheel is right below the tail. It's a tricycle usually in the fighter aircrafts. It's a multi-gear when the aircraft is very large. It's a bicycle configuration for lightweight aircrafts. Now the choice on the cabin, the fuselage choices that you have. You can have a cabin, which means all of your aircraft is just empty. There's nothing. It's just entire thing is cabin. Your pilot is sitting here, it's just empty place, right? It's a cabin configuration. You have cockpit configuration where people can only sit in the cockpit. You know, where do you find this cockpit configuration? It's an easy question. You should be able to answer.
In fighter planes, sir.
And where do you find the cabin configuration? What kind of aircrafts have cabin?
Commercial
Passenger
transport.
planes, sir. Passenger
Uh,
planes.
no, not passengers.
Cargo planes.
Exactly, cargo. And military planes that carry cargo. You've seen that people are sitting right beside this wall, right? And how about tandem aircraft? Where do you find tandem aircrafts? When you have tandem, you have one passenger here, behind him the second passenger. Seats are arranged like this. Where do you find tandem configuration? In personal jets. Have you seen any personal jet? You'll find tandem configuration. Side by side configuration. This is the typical civilian transport aircraft. Any aircraft you pick from Boeing or Airbus, they are side by side configuration. Okay. Now, what is important to a designer? The designer belongs to military or large civil transport aircraft, small general aviation aircraft, or you're making something at home. So what is important to you? It drives your design decisions, right? So yeah. Cost of the aircraft. For a military designer, cost is not a priority. That's why it has a number 4. When something is a priority, the number is low. So for example, for a home build designer, you have a cost is very high priority. You put it 1. Performance for a military designer is very high priority. You know, for large civil transport designer might not be so much. For the home build designer might not be so much. Flying qualities. Flying qualities means okay. So it should be a question to everybody. What is the flying quality? How do you define flying qualities of an aircraft?
Low turbulence.
I mean, turbulence is given by the atmosphere. So that's not in your hand. What is in your hand as a flying quality for the aircraft?
Sir, the flight should be smooth and it should not be very disturbing.
Exactly. That is the answer. Okay. So this is the flying quality. For a large civil transport aircraft, flying quality is important. So it's one priority. And for a home build designer, you don't give a damn about flying qualities, right? 7. You don't care. You just want to make it and fly. How about period of design? Since large civil transport designers, you have it as 9. You can take as much as you want, but you don't want to kill people. You don't want people to sit in an aircraft that is not safe. So the period of design, you can take as much time as you want, right? Now, beauty. Do military designers care about beauty of the aircraft?
Not at all.
Not at all. Now, you can see that stealth. Nobody cares about stealth. Only the military designer care about the stealth. So what kind of designer you are and you want to be as a person. So you should have a priority list in your mind. What you want from your aircraft. Okay. So this decision is driven by figure of merit list. You make a list and make a decision. What do you want in your aircraft? Let's move ahead. Okay. Now, this is how a design problem will look to you. Let's read it line by line. A 2-seat fighter aircraft is ordered to be designed to fulfill a military mission and meet the following mission requirements. Maximum speed, one of the quality. Absolute ceiling. What is absolute ceiling?
The height up to which an aircraft can go or maintain a climb rate of 100 foot per minute.
Isn't that service ceiling?
The absolute ceiling actually exists only on paper theoretically, but not actually. It goes to maximum ceiling, not absolute.
Yeah, so the definition you gave was for the service ceiling. Okay, so
Okay, sir.
radius of action. What is radius of action?
we can basically say the range of aircraft. That aircraft can go to 700 kilometers and come back 700 kilometers.
Right. Rate of climb, you understand. Takeoff run, you want your runway to be short, 600 meters, let's say, to be able to carry a variety of military stores with a mass of 8,000 kg. G limit is +9, highly maneuverable. So this is the kind of table you are given. So it's your question. Your job is to answer this question. The first question you need to answer is the configuration. What are you going to choose for the wing, for the tail, for landing gear? All right. So these questions you have to answer based on your experience. So design experience comes from solving more and more problems. So this is the nature of the problems. I've shown you one problem. All right, let's move ahead. We won't solve it because it's the first teaching session for us. So we won't solve this here. We'll solve it later on, maybe at the end of the course. Now, I was told that our duty is mainly to solve your problems. So I picked these problems from the previous year assignments. And this is, I think, the zero assignment, week 0 assignment. And this is the first question. Which one is generally responsible to generate the lift of aircraft? D, all of these.
Yes, all of these.
Yeah, Rohin has answered in the chat. Anybody needs any explanation? I think everybody knows it. It's a pretty simple question. I shouldn't spend much time on it. Let's move ahead. Induced drag for aerofoil is?
So theoretically speaking, it should be 0.
Anybody else?
So finite but not 0.
B. Finite but not 0. Anyone? C, B.
0.
0.
0. I think the answer is 0 because airfoil is an infinite wing. That's an assumption when we talk about airfoil, because if it has finite dimensions, then it becomes a finite wing. Okay, so when you talk about airfoil, it has to be an infinite length wing. So the induced drag is 0.
Sir, but induced drag is just induced drag, right? So if we are
Right.
choosing induced drag to be 0, that means the lift also should be 0, right?
Oh, how come?
Yes, sir.
Because if the drag is, that means there's a lift, and if there is a lift, that means there is a drag that follows because it's induced drag.
Sir, I
Oh
think
boy.
induced drag is because of vortices. And
That's
a
right.
single aerofoil cannot create vortices itself. It needs a span.
Right.
Really.
Okay, so let's move to the next slide. And this is where we explain why induced drag comes into picture. So you look at this picture. Can you see my cursor? I think you can. You see that this is the incoming flow. And since you have a finite wing, and then you have a trailing edge vortices. How these vortices are formed is explained in this picture. You see, when an aircraft is flying, there is a high pressure region below the aircraft, below the wing, and a low pressure region on top of it because the flow is fast. So the natural tendency of fluids, here air, is they go from high pressure region to the low pressure region. So they'll start going like that. They'll start going like that. Since the aircraft is moving, this kind of structure is made. Now you can clearly see that in the vicinity of the aircraft, of the wing, at the back of the wing, the flow is going downward. And because of that, there is a tendency of a downward component of velocity. So let's say this is V infinity. In the first picture, if you see my mouse cursor, so you see this is V infinity. There's a downward component W. So it basically bends the local relative wind by an angle alpha I. We call it, I think, induced angle of attack. And this induced angle of attack is is basically subtracted from the geometric angle of attack. And then we have an alpha effective. So that alpha effective is your lift producing angle of attack. So that's the explanation here for induced drag. In the next question, we have among the following, which aircraft instrument measures the altitude and speed of aircraft? I'm expecting your first. Yep, most people are answering A. Yeah, that's right. Good answer. Now, I'm not going to end here this question. I need explanation. So what is an altimeter? And sorry, you know the altimeter that it measures the altitude. But the question is, how does it function? How does it function? How do you compute altitude from a altimeter?
Sir, I can tell about old type of altimeters, how they work.
Go ahead.
So we have an opening which is in a pitot tube only, which measures the static pressure only. So as we go up on the altitude, the static pressure decreases, which will show us how much altitude we have gained.
Right.
Basically,
People in chat are saying atmospheric pressure, pressure difference in altitude. Okay. So let's find out how does the altimeter functions. Okay, so first is the pitot tube. So this is the shape of the pitot tube. Now, when there is an incoming flow in the tube, the flow stops. So whatever you experience is the total pressure. The total pressure looks like this: the static pressure plus the dynamic pressure when the aircraft is flying at speed v infinity and the density is rho. So that's your total pressure, and you subtract the static pressure from the total pressure, you get the speed of the aircraft. That's the air relative speed. Now, how about altimeter? So this is how altimeter functions. The altimeter is a sensitive pressure transducer that measures the ambient static pressure and displays an altitude value on the instrument dial. The altimeter is calibrated using the standard atmosphere. You have to underline this. The altimeter is calibrated using the standard atmosphere. Now, when you come back to this equation, your aim is to find out H, all right? And what do we mean by calibration here? To find out an H1 and a T1. So when the aircraft is on the ground, so you are at a certain height from the sea level. So that is your H1. So before taking off the aircraft, or on what kind of, in what area you are, so you have to find out the T at a certain height H. That's how you calibrate it. Then, since you are sitting in the aircraft, you know the current pressure, the static pressure. So by taking logarithm of this equation, you come down from the exponential and you can compute H. So this is how it gives the altitude, the altimeter. And just for your curiosity, how do you derive this equation? Anybody has any answer? How do you derive this equation? Okay, that's an exercise. You should go ahead and do this exercise to find out this equation. The only hint I will give you is that you find out the pressure gradient. You make a column. You make a column of the air and then take a height differential, dH, and corresponding to that, compute a dP and then perform the integration on that equation. So you will end up with this equation. All right. The next question is, weight is given for the aircraft and lift to drag ratio is also given. Speed of the aircraft is given, and they're asking us to compute the power in kilowatt. So I expect that you guys perform this question right now, sitting at your home. Just bring your calculator and start computing it. I'll go to the next question when I see answers in the chat. Okay, go ahead and do the calculations. I'll wait for answers. I'm looking at the chat and let's see who answers first. Rohan has answered 32.7. Rohan has answered almost every question that is there. Rohan, where are you from? You're not speaking. You're just writing on the chat. So I'm curious.
I'm from Bangalore.
Bangalore. And you are studying what?
Actually, I am a pilot, so I probably know many of these things.
Oh, you're pilot.
Yeah.
So you are doing your BTech or you are just studying this course for curiosity?
It's just for curiosity.
Very good. Nice. Nice to meet you, Rohan. You're answering almost every question. so I'm impressed with that. I'm waiting for others to answer. I'll need explanation also why this answer.
Yes, sir.
Yes, power is force into velocity. And how do you find the force? And what is force here? For everybody's knowledge, force here is the thrust of the aircraft. Now, how do you compute that thrust or drag? Because it's a cruise flight, so you can call it drag or thrust because they have to be balanced. Yeah, I'll probably start writing because
weight upon lift to drag ratio.
Yeah, that's good. Because for everybody's convenience, we have to write the equations. Otherwise, people will say.
Sir, is it 33.70?
I think it's 32.70.
Sir, 33. What's the answer, sir?
Maybe 30, maybe 32.
Okay, sir.
Yeah, you can find out. I'll just write down the equation. So you find out the thrust. You first compute the weight of the aircraft and divide it with the ratio of CL over CD. This ratio is given to you, and the weight of the aircraft is basically what? You have 1000 kilogram of aircraft and 9.8 is the G. You divide it with 15, that's your weight, and you multiply this number with the velocity because T times V infinity, this is your power. And you multiply this with 50, and then since you need the power in kilowatts, you divide
Yes,
it
sir,
with.
it is 32.7.
Yeah, so the correct answer is 32.7, and this is the procedure. Power is velocity times the thrust. This is how you compute the thrust, and this is the calculation shown here. I think we are good to go ahead. Next question is this. Yeah, the stability producing component for aircraft is.
May I?
Aircraft tail.
Aircraft tail.
Yes, sir.
People are saying tail. Yes, it's tail. To everybody who has answered tail, I want you to speak why not wing. You have to give me any reason, any reason. Otherwise, I won't accept the answer. Why not wing? It's mainly lift producing. So Akhileshwar Munisi, he's saying it's mainly lift producing. So does that mean it cannot have any effect on stability? Does it have stabilizing impact or destabilizing impact on the overall overall stability. Roll stability. Yeah. Wing has an impact on roll stability, that's guaranteed. But it has an impact on longitudinal stability also. No. Ailerons are for roll control, not stability. Stability is different from control. You will understand this in detail sometime later. Akhileshwar has answered it has ailerons for roll stability. No, that's not correct answer. Ailerons are to control the roll angle, not to provide the roll stability. Stability is a different concept from control, and you have to understand it very fundamentally.
Because we can't change the angle of the aircraft wing at which it is fixed, I guess.
But you can't change the aircraft tail angle also. It's also fixed, right? When you mount it, it's just fixed. You can only change the elevator angle. That's a control angle. So we are saying that the elevator is frozen. It's not changing. You can't change the elevator angle. Now tell me how aircraft wing can also contribute to stability. Karthik is saying contribution of wing to longitudinal stability is 0. No, that's a wrong answer.
Sir, wing is like a place mostly around CG itself, right? Mostly, I'm not telling it is, but mostly it is placed around CG. So it is usually stable itself.
That
Sir,
is
may I?
so. Yeah.
Sir, the wing is producing the lift and it is acting through the CP, we can say, the center of pressure. And it changes according to the angle of attack of the wing or the aircraft.
That's
So we can
fine.
say that affects the
But for
stability.
that problem, we have defined something called aerodynamic center, right? We don't
Yes,
care about where the center of pressure is. We compute everything in the reference of
around
aerodynamic
yes.
center. So we'll have some discussion on aircraft wing. Let's find out in the next slide. All right. So I took this from a book, and I want you to go through this. So you see the equation 2.7. It's giving us Cm, coefficient of moment of wing about CG. Cm, CG, W. The first thing in equation 2.7. It means pitching moment coefficient of wing, okay, about CG. It's given through this equation. Now this equation has two components, Cm naught and Cm alpha. Okay, 2.9 and 2.10 if you see that. And for a stable aircraft, Cm alpha has to be negative and Cm naught has to be positive. So for the aircraft, for the wing, Cm alpha can be made negative by basically adjusting CG and AC locations. So from equation 2.10, you see that Cm alpha can be negative, but Cm naught cannot be made positive. To make it positive, you need something, some different kind of arrangement. You need a negative cambered airfoil or a reflexed trailing edge airfoil. So I'll show you where it's written. It's written here. For a stable aircraft, Cm naught must be greater than 0 because you want to trim it at positive angle of attack. So a positive pitching moment about the aerodynamic center can be achieved by using a negative cambered airfoil section or an airfoil section that has a reflex trailing edge. Okay, but the thing is, the conventional aircrafts that we have, they do not use this reflexed airfoil or negative cambered airfoil. So their contribution is guaranteed to be destabilizing. Cm naught is negative, Cm alpha is negative. So for a stable aircraft to be able to trim at a positive angle of attack, you need Cm naught to be positive, Cm alpha to be negative, and that's why wing has a destabilizing contribution. So that's the full answer. Why not wing? You can have a wing alone configuration that is also stable, okay? But for that, you need some arrangement with respect to the what you call it, airfoil that you choose. And this is the contribution of the tail, right? So Cm naught is positive for the tail in equation 2.27. All you have to do is arrange the tail setting angle IT, right? Because it's minus here. So you can reduce it as far as possible. IT, you make it close to 0, then the whole thing is positive. VH is horizontal tail volume ratio. You'll see the definitions of these quantities later on. And CM alpha contribution from the tail is also negative. So tail is stabilizing component here. And since I'm showing you quantities that you might not have heard of, so don't bother. I'm just giving you some philosophical ideas here. All of these calculations you will perform later on in the course. Okay. So if you have not gone through a flight stability course, don't bother much. Just hear what we're discussing. Which book is this from? It's from Nelson. Robert C. Nelson. The book's name is Flight Stability and Control of, I think, Airplanes. You just Google Robert C. Nelson. I'll just type it in the chat. Let me type it. It's a good book. I recommend all of you to study this book before you come to this course, because here Ghosh sir won't be teaching you the fundamentals. You have to know the fundamentals already. He will teach you the design philosophy. That's different. He'll directly start speaking about connections between, like, if you change this, this happens, but you have no idea why that is true. So it's your duty to go through aircraft performance course or flight stability course. Both of those courses are must for you to able to perform really good in this course. Okay, so we now move ahead. If the weight of the aircraft is given and lift to drag ratio is given, thrust required has been asked in. So we have already done this question. Okay, when we computed the power, yeah, we computed thrust also. So this question is straightforward. Everybody can answer. So nobody is left. So I will move ahead directly without explaining anything here. And you can compute which one is the answer. I won't tell. Okay. If aircraft is in static equilibrium, it means what? Are controls set to 0? Are controls not set to 0? May or may not be set to 0. None of these. Somebody has answered something. A, controls are set to 0. Rohan is saying,
I think it is sir C.
Or may not be set to 0. Some people are saying C, some people are saying A. So there is a conflict. It could be A, it could be C. So I want to hear first from the group which has answered A. People who are thinking the answer is A, please go ahead and give us the explanation. Why do you think so? Karthik is saying stick fixed and stick free conditions. That's why may or may not be. I want to hear from the group A first. No? Okay, from the group C, if anybody can answer. Why answer C?
Sir, can I say?
Yeah, why not?
Sir, this is because whenever a plane is in flight mode, we cannot say what is stable and what not be stable. If an aircraft is stable at a moment, there might be chances that at other moment there will be instability due to change in pressure or due to wind gust. So this static equilibrium varies as per the conditions of the flight, sir.
Absolutely agree. They change, but still we have not found the answer to this question. I mean, okay, so I'll tell you about this question. The answer was given to me was aircraft controls are set to 0. That was the answer given to me from the NPTEL website. Okay. But I don't agree with that answer, because you can trim at a non-zero elevator angle. Okay, your aircraft is flying, but the value of the elevator angle is non-zero. Okay, so you can also have a zero elevator angle in pitch, whatever angle you're pitching at. So aircraft is still statically in equilibrium, but the controls are set to non-zero values. So I think a better answer would be uh, the derivative of aircraft control is zero. So it means that the elevator angle is not changing, but elevator angle has a non-zero values. We call elevator as we call it control surface. So if I say that control is zero, it means elevator angle is zero. But rather the question should be framed like this: the derivative, the change in aircraft control values, that is zero. Okay, not the absolute value. So I think the answer C is correct, but they have given answer A. So I'm not sure, to be honest, which answer should you choose. I'll go with C. May not be zero, maybe zero. Okay, next question is the weight of the aircraft is 1000 kg. You're given CL by CD, you are given wingspan, mean aerodynamic code, aircraft is flying at a speed that is also given, mean sea level is given, so you know the density of atmosphere here. What is the lift coefficient at cruise? Please go ahead and compute it fast. Let me open the chat and see who comes first. Okay, so no answers are coming. Oh yeah, some answer has come.
Start doing.
Yeah, 0.64. One answer has come. Let's wait for other answers. Okay, since no answers are coming, so probably people need help. Someone has come with 16.125.
Yes, sir, I've used the same equation.
So this is how you can compute it. I don't need to speak anything. You probably understand every aspect of it. If anybody doesn't understand, please tell me. Yeah, either it's 0.64 or 65, depending upon how much density you took.
Sir, can you please explain?
Yeah. So the idea is when you are given a mean aerodynamic code, which means you can consider a rectangular wing. Like whatever shape your wing had, doesn't matter if you know the mean aerodynamic code. If you're given a span of the wing, which is B, and a mean aerodynamic code, so you just take a rectangular wing, find out its area, right? So this is the area BC bar. B is given to you 10, C is given to you 1. So your area is 10 meters square. Okay. Now, when you are flying at a cruise, lift is equal to weight, and you know the mass of the aircraft. So your weight becomes 1000 into 9.8. So this is your weight. Now, from the formula for the lift, you know that it is dynamic pressure into area into CL. That's your formula for the lift. So I have already told that you are flying at a mean sea level. So you already know the density, which is rho 1.225 at sea level. And now you know everything in this formula apart from CL. So you just find out it by this equation. I think now everybody understood. If anybody
can we use that formula? V stall is equals to under root 2 W by S upon rho CL max.
But we are not flying at a stall velocity. We have been given the velocity, which is 50. Right?
Yes, sir.
The formula is exactly the same, but you should not call it V stall because we are not flying at V stall. We are flying at some, okay, not V stall.
Okay.
Yeah. Next question is the temperature ratio at 16 kilometer and 12 kilometer is.
Sir, may I?
Yeah.
It should be 1, sir.
Anybody else? Let me go ahead and see in the chat. No answers are coming. What should be the temperature ratio at 16 kilometer and 12 kilometer? Okay, I'll give you one hint. It's a factual question. You're not supposed to use any formula. You know. If you don't know, you don't know. Yeah. Shreyas has written that answer. According to international standard atmosphere, it's 1 as there is no temperature difference. So it's sort of a factual question. You know. If you don't know, you don't know. That's all. There is no formula to compute anything. Now, as a student of aircraft design, it's your duty to understand what is the atmospheric profile of the temperature. And for you, I have brought this profile here. So this is the profile. This is the temperature on x-axis, and this is the altitude on y-axis. Now, when you look at 10 kilometer, almost 11 kilometer, and 20 kilometer, you find that the temperature is constant, this value. Okay, temperature is this value, and it's constant. So you take a temperature here, you take a temperature at 16, 12, and 16, your ratio is 1. So again, I'll tell it's a factual question, but it's your duty to understand what is the atmospheric profile of the temperature. Let's go ahead for the next question. Yeah, you read the question and answer. I'm looking at the chat, and then we'll discuss when everybody answers. Akhileswar has said 1, greater than 1.
Yes, it should be greater than 1.
Should be greater than 1. Arijit D. I want to hear from Mahendra Reddy. Why do you think it's less than 1?
Sir, because in during takeoff, the weight composition is gradually decreasing. I think so. I am not clear, but I am thinking like that. During takeoff, maybe the aircraft weight gradually reduce so that it may be less. Am I audible, sir?
Yeah, you're audible.
Is that
You said like during takeoff, weight will be reducing, right?
Yes, sir. Ante ikkada here we mentioned no sir, rotation will be rotation in the point of view of rotation, sir.
So this is the, let me write it. Yeah. This is your runway. So aircraft speeds up, then rolls here, and then takes a climb. So this is the rotation they're talking about. So when you lift off from the ground, just right after liftoff. So this is the rotation they mean in this question. And during this rotation, you're supposed to tell what is the lift to weight ratio. See, one way to think about this question is this. You have a weight W sitting on the ground. You want to lift it. Obviously, you have to fire a force that is greater than W. Otherwise, it will be sitting on the ground. See, if I apply a force exactly equal to, let's say, any lift force equal to W, then it won't move from the ground. You won't accelerate. That's obvious, right? From Newton's laws of motion. You have to supply a force lift. It has to be greater than W. That's how you accelerate upwards. Now, when the aircraft is climbing, it's definitely in an upward acceleration. It's going upward, right? It's going horizontally forward also, but it's going upward. There is a climb involved. So there is an acceleration involved in upward direction. Therefore, lift is greater than weight while this rotation, and that's why the answer is D.
Okay, sir. Clarified.
Next question is this. So it's a big question. Note down the data. Everything note down your notebook because there are questions 2 to 6. They're based on this data. So you can refer it in your notebook. Just write down. First information you have to write down is the value of the CD. Then lift curve slope of the wing is 0.1 per degree. And zero lift angle is -1 degree, which means it's a cambered airfoil in the wing that you're using, and stall angle is 17 degree. All right, just write down this information in your notebook so that you can directly refer to it. I don't have to change the slides for that. All right, if you have written it, now we come to the question. The lift to drag ratio, it's also called aerodynamic efficiency at minimum power condition will be. So they're asking the question, what will be lift to drag ratio when minimum power, minimum P? That is the question. So I'll first wait for everybody, and then if you don't answer, I'll answer. Arun Balaji is saying something. In rotation. Arun, that you can say during the climb, okay? But it's the beginning of the rotation. That's what they've considered, and that's why the answer greater than 1. So your logic is absolutely fine.
Sir, it's A.
Rohin is saying 11.
Yes, sir. It's 11.
You're saying it's 11. Maybe it's 11. I don't know. But we'll wait for other people also.
Sir, I could calculate it, but I need aspect ratio for this, sir.
You need aspect ratio.
Yes, sir.
So, we have aspect ratio. So we don't have aspect ratio exactly, but we have something in which aspect ratio is embedded. And that is the equation for drag polar, CD. If you look at the CD equation, there are two quantities, 0.05 and 0.03.
A is given.
Now,
Yes, sir. From 0.03 we can
yeah,
calculate. So,
yeah,
sir,
yeah.
the Oswald efficiency factor E, we should take it 1 here.
You don't have to bother about that. You only need that 0.03 in your calculations.
Okay.
Yeah. Rohan is saying A.
Sir,
Yeah.
sir, some unwanted lines are on the screen, sir.
Yeah, I can see that. But problem is someone made them and he's unable to remove them. So we can't do anything.
Okay,
Sir, you may stop the sharing and then reshare it. Stop the screen sharing once and then reshare it.
Let's do this. Yeah, this is correct, man. Why did you tell us earlier?
Yes, sir. Now I got it.
Sir,
It
it's
is
11.
coming out 11.
It's
Yes,
11, then it has
Sir,
to be
it's
11.
still doing, sir. Sir, doing, sir.
I
Yes,
don't
sir,
see the
11.
lines. Can you see the lines are not there, right?
No, sir, the lines are not
Yes,
there.
now they have gone.
Yeah, we should have done it earlier. No problem. From next time, we'll be careful. Anybody who has not got the answer, like who is confused how calculations will be done?
Sir, me, sir.
Yeah, for you, we'll solve the question. So, number one question you should be asking is, what is the minimum power condition? I don't know, right? So for that, you need the formula for power. So power is computed like this. This is thrust, this is velocity. Thrust is computed from the weight and this CL over CD ratio multiplied velocity. Then velocity is computed from the formula for the lift and the weight, and this is the velocity. You substitute velocity here, you get a required power like this, and you find out this is the, I think there is some mistake here. Yeah,
So it's fine.
it's fine. So required power is proportional to this number. So if you want to minimize power, you have to minimize this number, CL to the power 3 by 2 over CD. Now, how can you do that? How can you do that?
Pardon, sir.
Yeah. Your job is to minimize this number. This is the number, and what you know already is this. CL is given CD plus some K, CD naught plus some K CL square. CD naught and K have some values, right? So you will try to find out the ratio of CL over CD, right? This is CD.
Sir, for minimum power, CD naught is CD upon 4.
I'm going from the basics, okay? For people who don't who have not taken the performance course, you might have known this number directly. Like if you minimize this number, then CL will be something like 3 CD naught divided by some K. You have both values, CD naught and you have K. CD naught is basically 0.0.
Yes, sir.
That number.
0.5.
Yeah, 0.5. And this is 0.3. You substituted. But for people who don't know where it came from, I'm doing this job. Okay. So what you have is the drag polar, and you compute this number, you put a power on, then you differentiate it with respect to CL, and then you make it 0. You will end up with this solution. CL is equal to under root 3 CD naught over K. And for that CL value, when you solve for CD, you will find out how much will be the CD, 4 CD naught.
Yes,
right?
sir.
Yeah.
Yes, sir.
And then you can find out
Yes,
the
sir.
ratio of CL over CD. So that's how you solve this problem. Okay. So see, try to see that it is mandatory that you learn the aircraft performance course first, because for those who have not taken the aircraft performance course, it might seem difficult. Like, where is this coming from directly?
So this was actually mentioned in the last lecture, like the
Yeah.
week 1 module.
Exactly.
Yes, sir, in module 1.
All right. So the lift to drag ratio at maximum range will be. Again, go ahead and compute. And this time I have given you the range formula also. So all you have to do is maximize the CL by CD.
So it's around 13.
Should be around 13, I believe. Let's see who else does. Akshay has answered 13. 12.9 to 13. Oh my God. I think the answer is maybe 12 or 13. And for those who do not know what to do, if you see the range formula for a propeller driven aircraft, it looks like this, and range is proportional to this L by D. So if you want to maximize range, you want to maximize L by D, which is basically maximizing CL over CD. And CL over CD looks like this, CD naught plus KCL square. You differentiate this number with respect to CL and put it equal to 0. You will end up with some solution for CL, which is CD naught over K, and corresponding CD will be twice of CD naught, and that's how you know the ratio CL over CD. You have CL, you have CD, you can just find out this ratio. The next question is the ratio of aerodynamic efficiency at minimum power condition and maximum range condition will be. So you're using basically the answers from those these two previous questions. So CL over CD for minimum power and CL over CD for maximum range, and this is the number. So answer of question 2, answer of question 3, you have answered question 4.
So it's always be under root 2.
What will be under root 2?
So it's the ratio will be always under root 2 because there sorry.
No problem. All right, so let's move ahead. The next question is find the angle of attack for maximum range condition. So from question 2, you should know CL, and based on that CL, try to compute the angle of attack. I won't tell the formula. I will wait for your answers. I've just given you the hint that you should know answer of question 2, CL. Some answer has come. 12.9 degrees. Very good. Answers are matching. No? No, I think that was the answer to the previous question. This time also is 12.9. I don't know what is the answer, but I know how to calculate it. So I'll just tell that for everybody's convenience. How do we write CL equation? We can write it as CL alpha, the lift curve slope, some angle alpha minus some angle alpha, L is equal to 0. And that's how we can compute it. So I think the slope is given. You have to find, it is unknown. This angle is minus 1 degree. And that CL you computed in the previous question, number 2. Same for question 3. You know the CL, you know CL alpha, alpha minus alpha, L is equal to 0. And that's how you can find out the another alpha for minimum power condition and maximum range condition. Maybe I have swapped the questions. Maybe it's 3 and it's 2. I don't know.
Yes, sir. Yes.
Yeah. Looks like it's 12.9 for the
Yes,
question.
sir. 12.9.
Sir, may you please explain this again?
What?
So may you please explain this again? That question previous.
Fifth or sixth question?
So fifth.
Yeah, definitely. So the idea is how do you write the equation of this line? It's CL. You know something called CL alpha, the slope of this, you know that. And one point on this line, you know, is this. This is alpha, L is equal to 0 angle. And how do you find CL in terms of CL alpha and the current angle? Let's say this is some current alpha. So when you find out the equation of this line, this is the equation of this line. CL alpha, alpha minus alpha, L is equal to 0. Okay. If you still don't understand, just expand it. You will find minus CL alpha times R is equal to 0. Okay, so this is kind of your intercept probably. This is your intercept of CL alpha into alpha. Usually the equation is CL is equal to CL naught plus CL alpha times alpha, and you don't know CL naught. So in a sense, this quantity is CL naught. Okay. So this is the short way of writing this answer directly. And if you want to understand it in the context of CL naught and CL alpha, then this is the answer. But you don't know CL naught, so you can find it out like this. Understood? Okay. One point of view could be like this also. Let's say this is the line, and okay, now just shift the origin here at this angle. Now, if I ask you, let's say this is the new origin. This was earlier origin, this is the new origin. So what is the equation of this line? Y is equal to mx. M is the slope, is the quantity on x-axis, y is the quantity on the y-axis. So what will be? CL is equal to some slope, CL alpha times the x. So what is your x? Now let's ask ourselves, this is the value that we're looking for. And this angle is represented from where? From here. Okay. And this is another angle. Alpha L is equal to 0. So you basically add them both because it's minus negative. That's why you add them both. So you know that whole length. And that's how you find out alpha minus alpha L is equal to 0. Because it was given as a negative number. Got it now?
Yes, sir.
Yeah. So for both questions, same method, and probably you have got the answer. 11.9. The next question, and we are also probably done with the assignment. I think week 0 in week 1, and in the next session we will take the new assignments. Assignment 1 probably. Have you have you submitted assignment 1 so far?
Yes,
No,
sir.
sir, but trying to solve the
Yes, sir.
question.
Yes, sir. There are some
Yes,
problems which
submitted.
we are unable to solve.
Okay. So wait for the Monday, because I can't tell you the answers, right? So we'll solve these questions on next Monday. Tomorrow again you will have a session from one of my colleagues. Okay. So there are 2 sessions for this course on Monday and Tuesday, 6 to 8. So she will be taking care of tomorrow. So the guys who did not join today can join tomorrow. And both of these videos will go on YouTube. So you can also watch it later if other people, because there are like so many people have joined in this course, like more than 6,000. So all of them don't usually join during the live session. So they can watch the videos if they want to. If anyone has any questions, they can ask, or otherwise we'll end this session here. It's usually supposed to be 2 hours, but we are done with the job, so I will probably close it.
Sir,
Sure,
if
sir.
you will
Thank you.
provide the PPT, it will be helpful.
Yes, PPT and videos, everything we will provide you. There will be links. So they will share you with the Google Drive links. Okay.
Okay, sir.
Yeah.
Sir,
Thank you, sir.
Yeah. Any question?
about the YouTube videos, what's the
Whatever
name?
what they will tell you. I'm not from NPTEL. I don't really know how they will send this information to you, but whatever we discuss in these sessions, everything will go to YouTube. Okay. And all of the links will be shared with people in the course who are enrolled in the course. So I don't know
Mostly
how
they
they
are
will
sharing.
say it again.
Mostly they are sharing in Gmail.
I think you'll get an email from them, from NPTEL.
But these
So I do have
live
a doubt.
classes are not.
Someone was asking other question. You can go ahead.
Sir, these live classes are not there, sir, in Gmail, sir. Only videos which are in previous day, which they took. That only we can see, sir.
Man, you're not really audible. Can you like can anybody understand him? I'm not able to understand him.
No, sir. We can't find that these videos, sir. Online watching videos, sir. We can find only recorded videos.
Okay, so you are saying like these live session videos you are not able to find on YouTube. Are you saying that? Okay, so yeah, I think in the next session, I'll probably, before the next session, I will inform the NPTEL people that you guys are having trouble finding recorded videos of live sessions. So they will divert you the links. I'll do that. Okay.
So I
Maybe,
do
sir,
have a doubt, sir.
Yeah.
I have a question, sir.
Uh-huh.
Sir, why the wings always placed perpendicular to the fuselage? Why not at a certain angle?
Not at a certain angle. Oh, okay. Let's take this question. I'll stop sharing and I'll share another screen. Wait. Yeah. So he's asking why, let's say this is fuselage center line or the reference line, and you can mount a wing on a certain wing setting angle IW, and you can mount a tail on some tail setting angle IT, or maybe at a positive angle, I don't know. But for the time being, I'm taking it at negative angle. So this is your wing. If the wind is coming from here And so this is your overall angle of attack, alpha. And your lift will be acting like that. Your drag will be acting like that. Now tell me, what is your question? Again.
Sir, I was asking why the wings are not placed at a certain angle. So they always placed at 90 degrees from the fuselage.
Oh, okay. Okay. Let me try to draw what you're asking. Let's say you are saying this is the fuselage. Are you saying they are mounted like this? Or are you saying they're not mounted like this? Or like this?
Sir, I'm saying why they're always mounted perpendicular to the fuselage. Why not?
Which is,
So
what is perpendicular? Case 1, case 2, case 3. Which one is perpendicular?
one. So first. Oh, so yes, first case.
So to your surprise, most airplanes are in configuration 2, not 1. Most commercial airlines, they call it something, they call it dihedral angle phi. Okay, so
Yes,
it's a non-zero angle. It's dihedral angle. It's useful for roll stability. Yeah, someone is also saying no. Yeah, definitely. Any other question? Right. So since this was the beginning week and you did not have much to discuss, from the next week
Actually, I
onwards.
am from, hello.
Sir,
Actually, I am from
I'm
second year. Hello.
Yeah, go ahead, Akshay.
Sir, actually, I am from second year and I want to do summer internship.
You
Could
want
I
to do
apply
summer
for that?
internship?
Yes, sir.
You can approach me on LinkedIn and send me your resume. Maybe we'll see what we can do.
Okay, sir.
Yeah.
Sir, even I'm interested.
Just send me your resume on LinkedIn.
What's your LinkedIn profile?
You will find it. I'm Vikram Sani, and you just type Vikram Sani, PhD, IIT Kanpur, you'll find me.
Sir, I do have a doubt.
Mm-hmm.
So, like, this is my first class. Like, I'm done my I'm doing my 4th year in mechanical engineering right now. Sir, you have said that before learning this course, like, I have to do another course relating to these formulas that we have discussed now.
Yeah.
So whether like any books are available, like any like recommended books are there for learning those courses, or it's available in NPTEL, sir?
There are books also. I'll recommend to read this book, Robert C. Nelson.
Sure, sir.
He has books on flight stability, and other book is on aircraft performance and design. There are 2 books.
Okay, sir.
So I will suggest you to go through both. Okay, sorry, this Robert C. Nelson has this book. This is from Anderson. This is Anderson's book. Aircraft performance and design.
Okay, sir.
Robert C. Nelson. Just write down these names in your notebook. Search on Google, you will find out these books: Flight Stability and Aircraft Performance and Design. Someone is asking, CL required. We can.
Sure, sir. Thank you.
From L is equal to W for given W dynamic pressure in wing area, but how actually CL available is calculating using wind tunnel for a given wing and surface area. That's done. That's pretty standard thing to do actually. Let's say you have a wing. What you really do is you put some pressure taps here like this everywhere, on the bottom surface, leading edge, trailing edge, everywhere. Now you have tons of tubes. Those tubes are these tubes. Combine these tubes, you set a manometer like this. Now this manometer will give you the levels of pressure, something like this. And now you have different tubes coming from different locations. All right. So these tubes will give you the levels of pressure in, and we compute that pressure by rho gh. So you know the entire pressure distribution on the top surface and the bottom surface. Then what you do, you simply perform integration. This is the wing. Now all you have to do is pressure and skin friction. F, perform ds, find out the components of lift, find out component of the drag. So this is lift and drag. All you have to do is through numerical integrations, because you only have data, you have tables, right? So you perform numerical integrations to find out the lift and drag in the wind tunnel. So this is how you do the wind tunnel experiment. Got it? Arun, Balaji?
Sir, is this your profile? Vikram Saini, PhD in flight mechanics and control.
Yes,
at
yes,
IIT Kanpur.
that is me. That is me. Send me your resumes and I'll see if I can help you.
Okay, sir. Thank you, sir.
Yeah. Any other questions you have, guys?
Sir, does this online class happens every Monday, or is it just designated for this Monday?
Every Monday and Tuesday. Tomorrow, my colleague will take this session. She will almost talk about similar things. She will have a different PPT than mine, but she will also solve the similar questions for you. Okay. So because we teach independently, so I teach some things, she teach other things, and then remaining things you see in the lectures of Professor Ghosh.
Sir, the links will be same or will be
Different
the new
links.
links will be
She has a different channel. I have a different YouTube channel, and we will both.
No, sir, I'm asking for every Monday we'll having different links or the
No,
from the same link.
same link for this course. The link you joined today will be for throughout this course.
Okay.
But for Tuesday, the link is different. For Monday, there is a different link. For Tuesday, there is a different link. Only 2 links for the meetings.
Okay, sir.
Excuse me, sir.
Yeah.
Sir, only this.
I cannot hear you, Suresh. No, you're not audible. You can write actually in the chat if you have any query.
Sir, I'm having a doubt, sir. Sir, about this entire flight mechanics, which is the beginning course which should start from, sir? Because the thing is that I started from second course.
So you should start with, I think, aircraft performance. Then you should go to flight stability and control. And then you come to the aircraft design course. So it's the final course. It uses both the previous courses. You come to this course later.
Sir, are those 2 courses available right now on NPTEL?
Ask again.
Sir, so are those 2 courses still available on NPTEL, sir?
I think so. They are available in YouTube or NPTEL website. They are available. Ghosh sir has taught both of these courses.
Okay, sir. Thank you, sir.
Yeah. I'm doing this course for first time. There were many queries in daily lessons and assignment how to clear it, which are the last 2 courses. I've told already. Aircraft performance and flight stability and control. So this is the 3rd course. The job of this course is to use the previous 2 courses to design an aircraft. So how does aircraft performance is computed? How is the stability properties are calculated. They are taught in flight stability and aircraft performance courses. So it's your duty to go ahead and watch the lectures of these two courses. Then you will be able to appreciate aircraft design course much better. Okay, so I think no one is asking any doubt. So we will end this session today. Someone is asking.
Sir, can you give rough idea on static margin? Just a brief.
Okay, so the rough idea is this. You have an aircraft, you have a wing, you have a tail, and it has certain lift and drag characteristic. It has a certain lift and drag characteristic. All right. So the thing is, where will the net aerodynamic force will act? There will be a point, right? So let's say that is the point. You call the net aerodynamic force is acting at this point. We call it aerodynamic center of the aircraft, and also you can call it the neutral point. So this distance is being measured from the leading edge of the wing. You call it XAC. Then you know the aircraft has weight. So somewhere its CG will be lying. Let's say this is aircraft CG and its location is XCG. Now the difference between the locations of XAC and the CG, they're usually measured as a normalized by the mean aerodynamic code. So this number you usually call static margin, I think. So for a good design, it's between 10 to 15%. So yeah, 10 to 15% of the mean aerodynamic code.
Okay. Okay.
Yeah. There is something in the chat. Sir, can you please write your full name? I'm unable to find your LinkedIn. All right. So for your convenience, I'm typing Vikram Saini. Then you just type PhD IIT Kanpur. You should find me. Yeah. All right, guys. Thank you very much for joining. I will meet on next Monday. See you then. Okay. Bye.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye.
Bye.
Yep.
Thank you, sir.
Yeah.